Okay, woo! Welcome back to the continuation of sketching a graph from extracting information from just seeing the equation. We continue working with the same equation, x squared minus 2x minus 8. Thus far, we have talked about concavity, intercepts, x and y. So we talk about axis of symmetry, but axis of symmetry is you actually indirectly learn axis of symmetry in learning maximum and minimum values. Right now we're talking about maximum and minimum coordinates. Now, if the graph has concavity of up, if the graph is concave up, then you'll be looking for a minimum coordinate value. If the graph is concave down, then you'll be looking for a maximum coordinate value, okay? Continue with this equation, which isn't excessively exciting, but it also isn't very complex, and it works that way. It's good to learn this stuff with a fairly simple equation. X squared minus 2x minus 8. And what concavity is this? This, well, what is A? A is 1. Knowing that A is positive 1, we know that it is concave up. Being concave up, we know that we're looking for a minimum coordinate value, an x and y coordinate value. Excellent, marvelous, great. So this is what you need to know to get the maximum and minimum coordinate value to sketch a graph properly. It may look a little, whoa, what is all that crazy math complexity? But it's really simple. First off, forget about the y. This is the equation for the y coordinate, that's the equation for the x. Forget about the y coordinate now. And to get the x coordinate for, in this case, the minimum, but if the graph was concave down, it would be a maximum coordinate, but we're looking for a minimum coordinate value. You just extract b from the equation and a from the equation and plug that into that little expression. So, from this equation, 1, a is 1, a, b, c. 1 x squared minus 2x, b is 2, minus 8. You just plug that into this and you get negative negative 2, b is 2, see? And then over 2 times a, in this case a is 1. Simplify that, 2 over 2, simplify that, 1. So that's it, that's the x coordinate value for, in this case, the minimum of the graph. And if again, if it was concave down, it would be a maximum coordinate value. So we know that that is x. Now this could start to make more sense. That may look a little confusing, but what you do is you just simply plug in the x value, in this case we learned it was 1, into the original equation. So now you can just pretend that negative b over 2a is 1, because it is 1 with this equation. So what is the equation when x equals 1? Well, you just plug that in. 1 squared minus 2 times 1 minus 8, that turns out to be 11. And that's that. And these arrows show how you end up with the maximum or minimum coordinate value, which in this case is 1 x value, comma, negative 11 y value. And then you can graph that. 1, comma, negative 11. That's the minimum value of the graph. From the previous information, you know that it's concave up, so it's going to go like that. And you can figure out x and y coordinates, the x-intercepts rather, and then the y-intercept, and then accurately graph the equation. Knowing that that's the minimum value, and if it was concave down, it would be maximum value. So there we go, that's how you extract the maximum or minimum coordinate for a graph just by seeing the equation of it. What is awesome?